Hi, my name is Isaac Stoutenberg, and I am going to present with my partners here, Matt Ruggiero and Sean Mosier, the Conversational Transcript System. Our client was SOU, which as a publicly funded state university is required to record minutes for certain types of meetings. Examples would be Title IX hearings, student disciplinary meetings, and Board of Trustee meetings. Our clients were Tom and Suresh, the CIO and the senior executive for equity and diversity at SOU. They were the ones who pitched the idea of putting together a transcription solution as a capstone project. Our goals are to automate the creation of meeting transcriptions, reduce the cost of these meeting transcriptions, and remove a transcriber's implicit bias. We came across a couple of challenges while we were building the system. One is that transcriptions are difficult and time-consuming to create and very expensive because of that. And the person transcribing the meeting will filter the meeting through their own implicit biases unknowingly. And with that, I will pass it to Matt.
So we decided to use a serverless architecture for the back end of our software. The code is all written in Python, and the transcription, storage, and database are all AWS web services. We used API Gateway to access our API. We used AWS Transcribe to do the actual transcription. The name of the serverless architecture is AWS Lambda. We used S3 storage buckets to store the audio files and serve the front end of the application, and we used Dynamo database as our database. For the front end, we decided to go with JavaScript and React for the front end, and we used Redux for state management. The way our software works is you record your audio through an audio interface. We use the PreSonus audio interface, but anything that will output a WAV file will work. And then you upload those WAV files into our system, and then we transcribe each channel of audio and combine them into an editable transcript. And up next, Isaac is going to give you a brief demo of our software.
Hi, this is a demonstration of the Conversational Transcript System. I'll begin by logging in to the web app. And once we're logged in, we will be directed to the Create Transcription Job page. And from here, we can create a transcription job. So we enter in a job name. We select audio files to upload. You can select multiple audio files up to a limit of 8. And now these files will be uploaded to Amazon, where they will be automatically transcribed by Amazon's transcription service. I'm going to head over to the View Transcriptions page so we're not just watching these upload. And here you can see all of the transcription jobs that I have completed as a user. This one here is a transcription of a Zoom meeting we had discussing our capstone with Maggie. You can see the transcription is broken up into the different participants. We get a confidence percentage on how accurate Amazon thought this particular chunk of the transcription was. And this is editable. So we can select this text and overwrite it. And then down at the bottom, we will have the option to save changes. Now, if we return to the View Transcriptions page and go back into that transcription job, we will see that edited text. From this page, we can also download and delete these jobs. Download will download a text file to your computer of that transcription. Delete will remove this job. and it removes it from the front end and also deletes it from the back end. We also have implemented an admin view, which if you are a registered administrator to the system, you can view all of the jobs for all the users that are logged in. And this basically takes you to that user's view transcription page where you have the full ability to view, edit, download, delete jobs. And that is the conversational transcription system.
Some of the features of our system are that we allow the user to upload audio files to our system. We allow the user to select audio files to create a transcription job that can consist of multiple audio files. And then we combine each separate transcription into one cohesive transcript. We allow the user to view all areas of low confidence and make edits to any sections that the transcription software might have had trouble. And we allow the user to download the transcript, and we also implemented an admin user which can view, edit, delete, or download any transcripts in the system. Some of our victories from last term were we developed a full stack web application. We put a lot of focus into designing it in a modular fashion so it will be easy to build on. We implemented persistent sessions so that the user could come and go as they please and they won't lose their place in our site. We completed transcriptions from multiple audio files. We encrypted all data that is stored in our site, and we deployed our first version. The victories of spring term were we implemented HTTPS, so there's no unencrypted access to our site. We improved the transcription algorithm. We implemented download and delete functions. We optimized the software and improved the overall speed and efficiency of the front end and the back end. We implemented an admin panel, and we can use Zoom recordings in our software. Up next, Sean is going to tell you about what he did this term.
All right, so this term I improved the combination of the different transcription files that we received from AWS to improve the readability of the transcript. I improved the efficiency of the back end of our system. I also implemented the delete functionality in the back end as well as the save functionality. I also documented and commented a lot of the back end code as well.
This term, I finished up the text editor so that it's a full functioning text editor. We can save, delete, and edit. I added the admin user class. I combined the view and edit components so it's a little more intuitive to use. I implemented a password reset function, and I implemented a middleware function that handles all of our HTTP requests and responses in one place. So it's easy to add or remove functionality.
And this term, I worked on a couple of front-end pieces. I implemented a footer, and then I worked on a delete function so you can delete your transcription jobs from the front end. I also did a lot of DevOps work, working on the deployment strategy. I put together a deployment script so that you can deploy the application easily, both the front end and the back end. I worked on implementing the HTTPS, so it's forcing HTTPS and will redirect HTTP over HTTPS using CloudFront and ACM. And then also did a lot of documentation of the software and client documentation.
Throughout this term, we had some issues with implementing HTTPS, issues with the backend database and saving that, issues with the deployment, and some issues when I was improving the algorithm that combines the transcripts. So the issues with HTTPS was that we had problems where it was redirecting errors because it was pointing to the wrong URL. Then some issues with the database is we were overwriting some data and saving incorrect data in inappropriate places on the database. So we had to go through and fix all of that. Then issue deployment. AWS tends to cache some of the scripts and files on the server for a specific period of time. And so when you redeploy it, it takes a bit of time for the system to catch up. And then improving the algorithm that combines the transcripts, that had issues because it would sometimes put other people in wrong orders of when they spoke. Through a bit of time, we managed to fix all those issues. So we compared our conversational transcript system to the Zoom Premium system. Zoom Premium and our system have about the same accuracy of 75%. Our system, there's no monthly charges. We only charge per audio file and when it's being used. It is only $1.44 per hour of audio usage. That's per file. So if you have multiple people in a single meeting, you have to pay $1.44 per each hour. Our transcription system was developed by Amazon for a backend, while Zoom was developed by Otter AI. And as you can see, the Zoom Premium is quite a bit more expensive, especially if you start getting up to 100 hosts, which would be more of a university level, such as Southern Oregon University. And that would be equivalent to 1,388 hours or 58 days of audio transcriptions, equal to the cost of 100 hosts. So our system is quite a bit cheaper for basically the same functionality. Our system is also significantly cheaper than having to pay for a person to transcribe these audio files. The Oregon minimum wage is $12 per hour. That is going into effect July 1st, so it is currently not there. So 1 hour meeting for a minimum wage cost would be $48. Well, ours is $1.44 per audio file. So you need 32 attendees in a meeting for it to exceed that limit. Client feedback, we received feedback from Tom and Suresh. Both liked how simple our interface is and intuitive it is to start transcribing audio files and how quick it returns the transcript. So our system also reduces the time it takes to transcribe a meeting as well as the cost. And AWS, the longer the audio files are and the longer the meeting is, the quicker it actually gets transcribed, because at the lower time, it's a 1-to-1 ratio, almost a 1-to-1 ratio. And then as you go up in the minutes, it becomes much quicker to transcribe it. And Tom also stated that this system could benefit him in captioning videos. So in conclusion, our software is intended to decrease the overall time required to transcribe meetings, significantly reduce implicit bias by the transcriber, who would unknowingly inject and cut down the cost of transcriptions. This software has a potential also to earn profit for SCU, as the need for transcriptions is universal to public universities, and the system can be sold as a service. Future work would include removing non-alpha characters from job names, including an application that records audio. So this would create a self-contained system. So instead of just accessing through a web browser or using separate recording software such as Reaper, you could do it all in one, so you wouldn't have to rely on other softwares. Also, being able to clean the audio files before transcribing them to improve the overall transcription quality, and also possibly being able to record audio in the browser to reduce the other applications that have to be used.